Hi students, in this video, I'm going to explain about properties of distribution function. So any function you can take. So we have some predefined conditions to become a random variable. And if you are taking the distribution function of that particular random variable, that must satisfy some properties. So now here, in order to explain the distribution function properties, I'm assuming one random variable x and the corresponding distribution function as fx of x. So for this distribution function fx of x, what are different properties to be satisfied? So now I'm taking the first property. The property one is fx of minus infinity is equal to 0. So we need to verify how this fx of minus infinity is equal to 0. So for this, I'm taking fx of minus infinity is equal to, you can write this as fx probability of x is equal to minus infinity. So when you observe this x is equal to minus infinity is an event which is also called impossible event, and the probability of this impossible event is always 0. So therefore distribution function of this particular event is also 0. And second one, fx of plus infinity is equal to 1. So we need to verify again this one also. So now for this, I'm taking fx of infinity is equal to probability of x is equal to infinity. And here, as per the distribution function, if I am taking fx of 4 means this is taken as probability of x less than or equal to 4. That means here we have to take probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 3 plus probability of x is equal to 4. Like this you need to take. That means whenever you are taking up to infinity means you need to start from the beginning. So what is the beginning? Minus infinity to plus infinity. The total summation you need to consider. So that's why simply I'm writing sigma x is equal to minus infinity to plus infinity probability of x. Okay. So then here, if you take the summation of all, it must be equal to 1. Okay. So therefore, fx of infinity is equal to 1. And the third property. The third property is from the two properties, fx of minus infinity is equal to 0 and fx of infinity is equal to 1. That means the distribution function must lies between 0 to 1. So now I'm taking the third property as 0 less than or equal to fx of x is less than or equal to 1. It should lies between 0 to 1. That means fx of x, the distribution function is going to increase monotonically, or it can able to follow monotonically, increasing between 0 and 1. Okay. And the fourth property. The fourth property is fx of x1 is less than or equal to fx of x2. So if x1 is less than x2. So when you take x1 less than x2, that means for x1, you need to take fx of x1, for x2, fx of x2. And from the definition of the probability distribution function, x2 is more value. So automatically x1 is less than x2 means automatically fx1 x1 is less than or equal to fx of x2. And the fifth property. So this is very important property to solve different problems based on distribution function. Probability of x1 less than x less than or equal to x2, that is equal to fx of x2 minus fx of x1. So now we need to prove this one. So I am going to write the function again. probability of x1 less than x less than or equal to x2, fx of x2 minus fx of x1. So the very important property. And to prove this property, I am considering two events. So consider two events. And now I'm taking event 1 as x less than or equal to x1, and event B consider as x1 less than x less than or equal to x2. Okay, and I'm also assuming that the two events are mutually exclusive. With the two mutual exclusive events, I'm going to prove the condition. So to prove this condition, I'm taking one more event, the probability of x less than or equal to x2. So probability of x less than or equal to x2 is taken as the combination of the two, because you need to take from the beginning to x2. So from the beginning means up to x1, this event is indicating, and up to from x1 to x2, this event is going to indicate. So that's why I'm taking the combination of the two, that is x less than or equal to x1 union of x1 less than x less than or equal to x2. Okay, and since the two events are mutually exclusive, then you can write, so take an example, A union B is equal to probability of A plus probability of B minus probability of A intersection B. So intersection of the two is going to be 0 for mutual exclusive events. Then you can write this as probability of A plus probability of B. Based on this principle, you can write this equation as probability of x less than or equal to x1 plus probability of x1 less than x less than or equal to x2. So now I'm writing this one as probability of x1 less than x less than or equal to x2 is equal to probability of x less than or equal to x2 minus probability of x less than or equal to x1. You can write this equation as fx of x2 minus fx of x1 based on the definition of the distribution function. Hence, you can able to prove this one by taking two events x1 less than x less than or equal to x2 is equal to fx of x2 minus fx of x1. Okay, and sixth property. So sixth property is fx of x plus is equal to fx of x equal to x plus epsilon. Epsilon is a simple infinitesimal increment value, so that is epsilon is greater than 0. But from this, fx of x is going to increase continuously, or continuous distribution function, and with the small infinitesimal small increment, there is no that much of deviation between the two distribution functions. Okay, so these are the properties of the distribution function. Thank you for watching.